To the cloud. There you go.
Well, welcome to the August 31st, 2021 session of TeamSpeak for Tangerine and Hamsai technical session. Tonight, I've been mostly working on other projects and not directly affiliated. I'm going to ask everybody, I would like to go through the whole roll call, but I'd like you, we have at least two talks that should take some time. And so I'd like to get through the roll call as quickly as possible. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Things are going fine here. Classes started today in Scranton. We're getting the Ham Radio Club going again. Just keeping everything moving forward. And I think we're doing fine with the TAPR talks for DCC. So those are into Scotty. Okay. W2NF, back to Nat.
Thanks. Next on the list is Dave, KD0 EAG. Go ahead, Dave.
Hello. Yes, I've just been working on some newer code with a different timing mechanism for the magnetometer. Not too much else than that. Back to you.
Well, fine business. And next on the list is Dev, KC3 PVE. Go ahead, Dev.
Yes, good evening, everyone. I'm just continuing with work that I am involved in. I think we're done with the algorithm development part. Now we're trying to get into the science. So we hope to make progress. Thank you.
Very good. And next on the list is Bill, AB4EJ. Bill, are you head above water?
Yeah, sort of. No, we haven't had anything but mild, light rain for the past couple of days.
Okay.
But most of the stuff has stayed well to the west of us. So project-wise, I've been working on two things. I've been working on the software for assigning processing PSK data so that there's CSV files that contain the sending and receiving call sign, grids, Latin long, and in cases where I can't get the call sign out of the PSK data because it wasn't provided by the user, I can sneakily look up the call sign in many cases using ham call. I bought a copy of that, and it even has an archive feature, so I can look up in the database and then fill in some additional call signs that way. So well on our way to processing about 4 terabytes of data for PSK for the NASA project. Also, I've been working a little bit on the the data coming from the magnetometer. This is probably something that everybody already knows, but there's a glitch in the readings. Every 8 seconds, it will skip one, exactly 8 seconds. I don't know if that provides any further information for Dave in his debugging, or anyway, I've got software that will go through and fix that, and just by holding that 7th over and repeating it once to get the 8th second, but that's just stopgap measure for purposes of being able to compare data. Okay, back to Nat.
Well, fine business. Next on the list is Bill in 8ET. Go ahead, Bill. Oh, can't hear you. I can see you talking.
Did that help?
Yep, that helped.
Okay. Yeah, I had.
Oh, you just went quiet again. There you go.
Well, if I get a slider won't stay up, but I don't have anything to report. I had this week.
Well, we got that you don't have anything to report, so thank you. Next on the list is Dan in for XWE. Go ahead, Dan.
Thanks, Dave. Well, good evening, everyone. I spent last week in Duluth, Minnesota, at least the end of the week and part of the weekend. and back in North Carolina now. So using Windows for the first time in quite a while. It's very exciting. And back to you, Dave.
Okay. Next on the list is David in one HAC. Go ahead, David.
Good evening, everyone. Spent the week working with existing SDRs and working on solar power systems. Back to net.
Well, fine business. And next on the list is David Waugh, KE8 QEP. Go ahead, David.
Hello, everyone. This evening, I've been working on more magnetometer stuff, but I'll be brief. So back to Dave.
Okay. Next on the list is Gary, AF8A. Go ahead, Gary.
Good evening, all. Spent a little time this week at Hillman's request reviewing the magnetometer instructions. Found them to be very, very good. And I got the same back to him. So back to net.
Fine business. Next on the list is James, KG4 DSG. Go ahead, James.
Good evening, Dave and the group. Nothing to report here. Back to the net.
Fine business. And next on the list is Jay, WB8 SBI. Go ahead, Jay.
Well, there we go. Good evening, everybody. I'm going to join the crowd and say nothing new or of interest to report here. Hope everybody is staying safe. Take care, and I'll just be reading the mail for the rest of the meeting.
Okay, next on the list is Joe, W7LUX. Go ahead, Joe. Oh.
Are we there, Dave?
He's in another instance.
Last instance froze. Are you there?
Your audio is very low, Dave.
Okay, I'll adjust it again. Okay. Let me get back to where I was.
Yeah, Dave, your audio is still not coming through.
It's like, yeah, I've got 2 instances.
I think several folks are getting routed through New Orleans.
Where all we hear is water running.
Yeah.
It's funny, Dave was fine a minute ago.
Nothing like Louisiana, but we're expecting a bunch of rain in northern Arizona.
Yeah, from Hurricane Nora.
And a resumption of the monsoon.
And a resumption of the monsoon, yeah.
We've got some burn areas that are a problem.
What, previously burned and now subject to washing out?
Flooding, Flagstaff.
Yeah, but is it previously burned areas? You don't have any fires going now, right?
Correct.
Did you hear about the one in Tahoe that's threatening the village there?
Yeah, it's pretty bad. So where's our MC?
Or
Can you hear
Joe.
me?
Yes.
Yes.
Okay. Joe, did you give your talk?
Yeah, nothing to report. Over.
Okay. Next on the list is Jonathan, KC3EEY. Jonathan, we'll give you some time after we get through the roll call to give your presentation.
Hi guys, sounds good, Dave. Everything was in the email. I was tweaking my settings on my Raspberry Pi box, and everything will be in the presentation later.
Okay.
Back to the net.
Next on the list is Jules, K2KGJ. Go ahead, Jules.
You are muted.
Jules?
Yes, there, you're. Oops, you're muted again.
Still muted.
Yeah, there we are. How about now?
Yes.
Now, that's good.
Okay, good. Yeah. For some reason, the space bar wasn't working. Number of things going on this week. Nothing particularly to report. Still working on several projects and back to net.
Fine business. And next on the list is Michael, AAAK. Go ahead, Michael.
Greetings to everyone listening. Back to you, Dave.
Fine business. So, Scotty, did you give a report when I was out?
No, I did not.
Go ahead, Scotty.
Just
W2.
Okay.
WA2, DFI.
Just still waiting on the magnetometer prototype build, and see what else. Oh yeah, I got the clock module evaluation boards from John into rework, and they're being reworked now. And I just got the packages today for the GPS evaluation modules that he wants me to have the CM solder the GPSs down, because they got an array of pads, so he can't do it with an iron, so we have to do it with hot air. So that should be taken care of this week. And other than that, that's it for this week. Back to you.
Fine business. And I think we've got Tom, N5EG. Go ahead, Tom.
Oh, good evening. I'm trying to get back on the Fpga learning course. This is a long, tall hill. Scotty, I found XA15 at the receiver schematic. Is that current?
No, I just sent you XA19.
Okay, very good.
Which is the Rev A. That should be Rev A. And the names of the signals, if you trace them through, I think are correct, because I checked them after you sent me that note. But we could talk afterwards if you want to.
So Tom, do you have something you want to present about your testing later?
No.
Okay, I thought that your note indicated you might want to have some time to talk about it.
No progress in the last 2 weeks.
Okay. Well, at that point, I think I've called on everybody. Oh, there's a new person, and Nathaniel, do you know this person? Because I
don't believe I do.
I don't know how to pronounce their name.
Nachiket?
Deshpande?
Deshpande? Are you there?
Hello, yes, this is he.
So how do you pronounce your name, just so we get it right?
Sure, the name is Nachiket Deshpande, but I go by Nachi for short.
Okay. Well, that's easy. Go ahead. Welcome to the list. And what's your interest?
Oh, well, thank you. Thank you for having me. So my name is Nachi, call sign Kilo 6 Tango Charlie Zulu. I'm relatively new to the ham radio hobby, but I'm working on my general license, studying up for that. And I'm actually an engineer interested in atmospheric and space physics. And so I'm kind of prepping for grad school, and was really excited to hear about your projects and just wanted to learn more.
Well, very good. Now, a little question. Have you ever done any FPGA programming?
You know, it's funny. I haven't, while I haven't actually programmed FPGAs, I used to work in the jet engine industry, and one of my big projects involved FPGA related testing for jet engine control systems. So
Oh, we can use testing as well.
great. Yeah, I used to be an engine control systems engineer.
So we're going through some backflips with getting FPGAs and getting them built, and we all know just enough to be dangerous and not enough to be an expert.
Okay, all right. Hey, not a problem. Yeah, I think that's sort of where I am too. So.
That looks like a Cessna. Are you a pilot?
Yeah. In training. Yep. Just got the check ride left, and then of course the pandemic and other things have sort of put that on hold. But yes, that's correct.
Okay, good for you.
And you may or may not know this, but Dan in 4XWE is a instructor.
Oh, excellent. Well, very nice to meet you. Very nice to meet all of you, actually.
So I think we're done with our roll call, and so we'll be open for general discussion. And at least Jonathan wanted to talk about his recent developments with the very low frequency receiver module. Go ahead, Jonathan.
Okay. Yeah. So what I did was I was able to finish up the audio interface board and the power interface board in my Raspberry Pi box, and I was actually able to get the whole system up and running with VLF RX Tools software. To my surprise, the filtering worked pretty well. The antenna is actually underneath some trees and underneath a power line. So there's still some considerable power line hum. It's hard to avoid it in this area. But what I wanted to show you were some graphical programs that aid in setting everything up. And this will give you an idea of how everything works. So I'm going to share my window here. Let's see. Okay. So right now I'm sharing the first program. This is called VT Scope, and it allows you to look at the screen in real time with an oscilloscope display. It's actually very handy for debugging and understanding what's going on. What you're looking at right here, this is the pulse per second pulse from the Trimble GPS receiver. This is fed into the left channel of the audio injector stereo sound card. I highly recommend audio injector series sound cards for the Raspberry Pi. They work quite well. This has a maximum sampling frequency of 96 kHz. This GPS pulse per second is used for time stamping the input signal. One thing that you'll notice is at the top here, it's a little clipped. That's because what I have to do is that I have to put a resistor divider in there and lower that level just a bit. There's a potentiometer on the sound card that you could adjust the gain, and I was able you don't want this clipping, because the program that tries to align the timestamps to UT time, it's looking for this edge pulse right here, and it works really well. But this clipping introduces some occasional timing errors, and when I adjust the divider on the potentiometer, then it goes away. So that's something that I have to do. I'm going to short the other part of the pot. That's the audio signal coming in from the VLF receiver. So this is actually pretty important here. And a little tidbit, you'll notice right here, it's pretty close to the 100 millisecond mark. If you guys ever tried to set your ntp.conf time one value for using GPSD to steer NTP, this is a quick way to get that value. This is about 4 milliseconds, which means that there's 4 milliseconds lag between when the actual second occurs and when it is seen on the system. So this is a handy way to get that value, just in case. The other window here, let's see. This is the oscope display of the VLF receiver. This is raw VLF receiver audio. And what you'll notice is you could see a 60 hertz frequency here based on the time scale. This is 60 hertz power 60 hertz power line hum from the power lines in the environment. You'll also notice very heavy harmonic content. And so the filter is a tracking filter to filter out this hum. What it does is it looks for the fundamental 60 hertz. But as you know, that frequency varies throughout the day. So what it does, it'll look for the fundamental, and then it'll start to track it wherever it goes. And it will also automatically notch out and track the harmonics. And that's how Paul was able to get this working so well, where you could listen to VLF signals in a suburban environment or a environment that's radio quiet, but there's still power line on. It's unavoidable. One of the things you want to make sure is that the level of power line hum doesn't overload the sound card, because in that case the filter won't work. And on this scope display, you could change all the settings and everything. You can have it trigger on the channel, or you could have it trigger on universal time, change the capture length, resolution. It's a very handy program. The third window that I wanted to share is the spectrogram display. Now this is actually a lot of fun because—
Jonathan, before you switch from, or at least can you answer why the phase is changing so rapidly? The power line is a controlled frequency. It shouldn't be drifting that quickly.
You mean on the scope display, right?
Yeah, on the display. I mean, you're triggering on UT, and the power line is a time standard. It shouldn't be drifting that quickly.
No, well, I believe it has something to do with how it triggers, because, and also how it samples as well. I'm not sure why it doesn't stay constant, but it should. I haven't really played around with the triggering to get it constant. So far in my tests, it would it would creep a little bit like it's changing now, the phase.
Okay, I'll have to take a look at it. I don't have, my system doesn't respond that far down, but maybe I'll make it do so and see what it looks like here. Thank you.
Okay, yep. So this is the spectrogram window. I have it set in resolutions of 1 Hertz, and you can see the power line harmonics. This is 60 Hertz right here. This is 120. This is 180, and so on. And you can see it's the odd harmonics that contain most of the energy, which is pretty neat. If you change this is the full spectrum that you can see. You can see that most of the spectral power here is close to where the mains hum is. This is really cool to see what sources of interference that you might have. Dev, can you unmute your mic, please?
Okay.
Thank you. So here we could see some peaks, 1 at 20 kHz, different peaks, and I believe, at least in my environment, they're probably due to switching power supplies. But I haven't been able to really pinpoint them yet. I haven't really studied their content.
Jonathan, it could actually be the older transformer type wall warts. They put out a lot of 60 Hertz harmonics.
Oh, really? Because I'm actually using one to power the Raspberry Pi box, so that's something I might try.
And what happens on that when the diodes recover? It's like a snap recovery, and then it excites the any winding inductance, stray inductance, anything. They get very, very noisy, the old ones.
Oh.
Yeah, good ones will put 0.01 capacitors across the diodes, but they often cheap out and don't do that. And so you can get a lot of garbage coming off of the old linear wall warts.
Oh, okay.
And they will be at, because they're full wave rectified, they will be at the odd harmonics.
Yep.
Oh, okay.
Well, actually, that's even harmonics. That's 120. Huh. Yeah, why you're getting odd harmonics is actually a clipping phenomenon. Somebody's clipping somewhere. But yeah, both.
Okay. Because I was going to try different power supplies, because the one what I was getting when I was testing it last week, I was getting under voltage errors on the Pi, and I checked the DC to DC converter that I'm using to power the Pi, and I had to tweak it a little bit to 5.1 volts, but I wasn't sure if that was the wall wart, because it's a 12 volt, 1.5 amp wall wart, and I'm not sure if.
Jonathan, if the wall wart is what you can do is take a little portable AM radio, hold it next to the wall wart. If you hear a loud buzz, then you've got RF noise coming from the recovery diode, or snap recovery of the diode.
Okay. Okay, I will.
Yeah. It can also be just any old power supply is going to, if they don't do power factor correction,
yeah,
they will conduct in very short pulses on the peaks of the 60 Hertz, and that will give you that odd harmonic street.
Okay. Okay.
Often you can put a line filter between the power line and the power supply and filter that out.
Okay. Well, this antenna is directly under some power lines. It's a bad place for it, but it's the only place that I had for the demo, and I believe that those harmonics are being radiated from the power lines, not necessarily from the power supplies that I'm using. So and that's normal. Filtering software will be able to filter that out. So
you might try turning your antenna, seeing if you can null it, or if it at least changes relative to the orientation with the power line.
Well, it's an E-field antenna. If it was an H-field antenna,
even at that, no, it'll still be polarized along the wires.
Right. Yeah. I probably need to relocate it differently. I mean, I'll still get the harmonics. It's still gonna pick those up from the power lines, but the filtering software will be able to filter those out. Once this is in a radio quiet location, then you're going to have much easier time trying to filter everything out. So I would like to believe that these peaks are VLF transmitters too, but and they might be, but
well, I certainly see NAA in there. That's at 24 kilohertz.
Yes, actually, yeah. This peak right here, and that's very exciting.
And the peak above 40 kilohertz could be Puerto Rico.
I think so. Yeah. Yep. So the SID monitor program that will actually monitor the stream. What it does, it'll crop in frequency everything but the frequency that you set to monitor. So you could monitor NAA, you could monitor different sorts of transmitters for their amplitude and their phase. And what it'll do, it'll output CSV files with that information, and then with the plotting program, you could actually generate plots, and that's what I want to show you next. Because let's see, because the because one of the really cool things is this program. It's called VT SID. It will monitor any transmitter that you have it set to. There are certain transmitters that are not useful for this purpose, but it can be used for monitoring SIDs, which is really cool. I have to re-log in here. One of the problems is that when you close in a X window and you try to run another X program, it gives an error, so you have to log in and out. Oh, here it is. So let me share this one. This is just GNU plot right here. So this is a plot of NAA that it's monitoring. Normally when a disturbance comes through, you'll see an abrupt change in amplitude and phase. So I thought this was really cool because there's a script that allows you to read the data, and it invokes and it generates this plot. So we could monitor NAA, we could monitor DHO, and you can see what you can get in your area with VT or with VT spec, the live spectrogram. So this is one of the cool features. I also have the event detector running, and that is looking for chorus and whistlers in the stream. That requires almost no configuration. It looks for rising tones and falling tones, and if it detects, say, like a whistler or chorus, what it'll do, it will make an audio file of the event. It'll make a spectrogram image of it, and it'll generate a text file with some information. And for long chorus events, it will also record the whole long chorus event. So sometimes chorus events could last, tens of minutes, hours even, and it'll record the whole thing automatically. The drawback is since chorus is rising tones, so are motors that start up, like power tools and washing machines and things like that. They are often seen in the event detector. And if you look in the directory, you'll see these false events. So what you have to do is you have to go through and delete those false events, and then you'll have the what you have left are the real ones. VT-SID doesn't have a lot of doesn't have any automated detection capability. So what you would do is you would note the time of a solar flare or a geomagnetic event, and this will show the in intervals of an hour. So you could actually look for the event, and it'll tell you when it happened. And remember, since the stream is GPS timestamped, you're getting the exact time that the event occurred, and it could be correlated with other receivers also running GPS timestamping. And lastly here, there was a screen that I wanted to share. This one. Not this one here, but so this is the log output of the VT time program. So what VT time does, it reads it looks for the GPS timestamp through one of three methods, and after it finds it, it generates an offset for each timestamp. So the VT card program reads from the sound card, and it timestamps it according to the clock of the sound of the system. And so even though that you might have NTP set up and your clock is pretty accurate, there's still some errors. So VT time generates an offset for each timestamp to adjust it to UT. Normally everything actually runs pretty good. You can see here ST2 means it's in a running state, and sometimes you get errors like this invalid phase slope and wild the wild PPS pulse interval. that's because of that clipping that I was showing you on the first screen. Once I change the divider, that goes away. I spoke to Paul Nicholson, who wrote VLFRX tools, and he said that this log looks really good. So it's so I could further improve it by using a divider, and that'll make all the errors go away, and I'll have even better performance. And so the data is stored on a USB drive. So I have a events directory that stores whistles and chorus events. Obviously, that's empty. The SID stores the CSV data. You can see this is the data that I had taken. This is just in regular CSV format. I also have, so I'm storing a the raw data at 96 kHz. So it what you can do is you can use the program called VT Read, and if you have an interesting event or something like an amateur radio transmission, you point it to this directory and you give it a time, and it will output the time that you're into, and then you could send it to a spheric blanker, which will blank all of the spherics. It's not perfect, of course, and then you send it to the program that can do the coherent BPSK decoding, and you may be able to see the message, or if they're just sending a carrier, you will you could see a peak on the time plot. Also, I also have data resampled to 32K. Sometimes you're just interested in natural radio, so you don't really need all that bandwidth anyway. And I have a script running. Every 5 days, the 96K data will get deleted, the oldest files, so the disk doesn't fill up. And with the 32K data, it'll I believe after 14 days. So if any interesting event happens, or you know, whatever it is, if you want to study spherics or anything that you're into, there are the tool set can get from this data store. I also have it set with it can stream to another system running VLFRX tools, not just a listenable stream, but a full data stream where it could be written further to disk and further processed. So if you have a, say if you have 2 H field loops and an E field, you can do lightning location. It'll give you toga data. And if you have multiple receivers, you could take all that data and it'll give you coordinates of spherics. Obviously, the more receivers you have in the area that you're interested in, the lesser error that you're going to get. So this is just a brief overview of the system. This all runs on a Raspberry Pi. You can see these are all the VT card programs, and they don't really use that much power on the Pi. You can see this is the CPU and the memory that they're using, and there's actually room on the Pi. You could run even more things if you needed to. So it's the Pi 3B is actually really good for this. And you could verify that your GPS is running. I have GPSD running, and the pulse per second signal is not only fed into the sound card, but it's fed into a GPIO pin. So it keeps really accurate time. So right now it's using SHM2. That's the pulse per second from GPSD. So that's it so far. It's actually pretty exciting. It's really cool how all this works, and I'm excited to get Whistlers and other events. Just in case people didn't get a chance to see it, I will post the live stream that you could listen to. Any player that supports Vorbis can decode the stream. You'll notice the higher frequency components of mains hum. That's because I'm right under the power line. There's a lot of harmonics, but the filter actually works pretty good, and it gets the fundamental really well. And you hear spherics and tweaks mostly. So yeah, that's all I have, and everything worked out pretty well. What I'm going to do is I'm going to improve the system. I'm going to add the voltage divider to fix those timing errors and make sure that the pulse per second pulse doesn't clip. And then once I do that, then what I'm going to do is I'm going to get the audio injector isolated. That's a 192 kilohertz sampling card that uses the CS4272. I'm going to have to modify the holes a little bit for where the Pi is drilled in my box, just to get everything to fit. I don't know if it'll fit, but I'm going to see if I can make it fit, and everything's pretty snug in there now, but I'm going to see if I can make it fit. This way it'll have 192 kilohertz sampling, and we could do some serious work with amateur radio and SID monitoring. And that's all I have. Thank you for your time.
I think that looks very comprehensive, Jonathan.
Thanks. Yeah, that was that kind of covered everything that I ran into, and it's just cool to kind of play around with it. Finally, to get signal coming in and looking at my local VLF spectrum. So it's so there's definitely more to come. There's much more that this tool set and the system could do.
That's excellent.
Thank you.
Jonathan, what card was it that you said you were going to get that's 192 kilohertz?
That's the audio injector isolated. If you search on the audio injector, it's from Flatmax Studios. If you search Flatmax Studios, he has a store. And he sells different versions of his audio injector. I'm currently using the audio injector stereo. That's a two channel. It's based on a codec from Wolfson Micro. There's also the audio injector Octo. That's a 6-channel sound card, but it can only sample at up to 48K. That could be pretty useful if you have H-field receivers and you need more channels. And what I'm going to use is the audio injector isolated. The claim is that the audio path is isolated from the rest of the circuit, so it's much lower noise. I don't know how well it'll work. I hope it'll work well. The only thing I have to do is just change a line in a text file and update the kernel, and I should be good to go. So. Does anyone else have any questions?
Just for the recording, I wanted to mention that Bob McGuire jumped in there and I don't see him anymore.
Oh, that's a bummer. I definitely wanted him to see it. Well, I could just email him the YouTube link. Does anybody have any issues listening to the audio link that I posted?
It worked for me, Jonathan.
Okay, good. So, oh, also there's an IceCast server running on the Pi that allows you to have live streaming. So anywhere on your LAN, you could listen to it with whatever software or music gadget that you have. You can also upload to an internet server. Say like so Paul has a network of these receivers running, and they are all they all upload to a Amazon Cloud instance running Linux and IceCast, and he has links on his website to listen to various VLF servers around the world. His is in the UK. The creator of Spectrum Lab, his receiver was offline, but he was streaming for many years until recently. Not only do we have VLF data that's backed up and time-stamped, we also have data that we could stream for live listening. If you want to listen, you know, let's say if you want to listen to tweaks in the summertime, they're very plentiful in the summertime due to thunderstorm activity. So you could hear them really nicely. There were some nights that I would listen, and you know, they would be almost constant. Yeah, there's an IceCast server running on the Raspberry Pi now, and that's actually what we're logging into. So I'll take it down once everyone's done here. Any other questions?
Is the system design published somewhere, Jonathan? Like if I wanted to build such a system?
Not yet. The schematic for the receiver was posted in a VLF Facebook group, and Paul built and the this Pi system was originally built for an MIT study. I'm still trying to track down what study that was and who the PI was, but Paul Nicholson, the creator of VLFRX tools, he built a bunch of these antennas and a bunch of these Raspberry Pi boxes. So they could be installed in different areas and upload to a server at MIT, but I'm trying to track down exactly where that was. But on Facebook, there's a VLF group with that information. Paul also has pictures of his Raspberry Pi box. I plan on publishing more information, but if you ever get interested in wanting to build one, let me know, and I will get you the right information, and I will help you out with the construction.
Okay.
Oh, and one quick thing: the VLF module for the TangerineSDR, that's going to replace the VT card program and the VT time program. So what you'll get from the Ethernet will be a stream that could be sent directly into the VT filter program, and also the VT SID program. So the setup for this to get the GPS pulse per second timing right, and get the sound card buffers right and everything, it could be a little difficult. I had some difficulty using OSS drivers on FreeBSD, but this module that will take the place of VT card and VT time, and it will output a timestamp stream ready to be processed. This system, eventually this is going to be replaced with the VLF module on the TangerineSDR. And I have, in my test box that I built, that has an audio output, and that will feed into the module. Everything will be taken from there. So right now, this receiver, there's DC power and audio on a Cat5 feed line that goes out to the antenna. So I built this box to power the receiver and have an accessible audio output that will go to the VLF module. Any more questions? All right. Well, thank you, everybody. Thanks for letting me show you what I got so far. I was really happy with everything, and I'll just continue working on this.
Thanks, Jonathan. Great for sharing.
Yeah, I agree. I think this is really good work, Jonathan, and I'm glad you're doing it.
Thanks, guys.
Dave, are you there?
I'm here. Can you hear me?
Mm-hmm.
Well, we are at our time for an hour for people that need to go. Any other topics?
Scotty, did you want to say anything about your schematic?
The adapter?
Yeah.
Yeah, is Tom still here?
Yes, still here.
Yeah, so Tom has sent me an email. I sent the schematic off to Tom and John and a couple others for review to see if we're on board. I mean, if I made any dumb mistakes, let me put it that way. And so we're basically reviewing that to see where we're at. And it's as far as I'm concerned, it's done, plus or minus the mistakes that we're going to find to correct. So.
Okay. Scotty, thanks for sending me the updated schematic. That'll probably clear up the issues I had.
Yeah, the thing is that's confusing is that the connector is labeled with the labels off of the data engine. And then when I connect it over to the HSMC connector, I use that same label so the schematic will connect the signals up, but then I put in text the label for the signal on the RF module. And I think I changed those because they became, instead of 1.8 volts, they became 2.5 volts. So it may look confusing, but because you wisely put the voltage as the suffix for the signal name. So when we went to 2.5 volts on the FPGA banks, I changed those to 2.5 volts. And even though the A to D converter is 1.8 volts, since we set the IO to LVDS, that we have to set it to 2.5 volts to get the proper common mode voltage for the 1.8 volt outputs of the A to D. So kind of weird that you have a 1.8 volt IO A to D and you have to connect it to a 2.5 volt bank to make it work. So it's strange, but I mean, but we caught that. So that, and those SPI pins go to the same bank. I mean, all the IO pins are the same voltage, so they get set to 2.5. So we had to do those funny resistor divider things to make sure we didn't. But the FPGA is 3.3 volt tolerant, but the ADC is not. So
yeah, I noticed some 1K pull-ups I think you had on the board.
yeah, and I think you commented on what they were, and I changed the value to match what you suggested they should be.
Okay.
I think I had them as much lower value, and you suggested that was not going to work because they were too low in value.
Yeah, they needed to be up around 10K is my recollection.
So did I put them at 10K or did I put them somewhere else?
I don't know. Let me go back and check and compare against the new receiver schematic. And
okay,
by looking at the wrong schematic, I could have messed up. Let me go back and double check.
Yeah, because the Rev 19 there is actually the Rev A. That's the one that is complete, sitting here ready to go build. So
okay, I'll get on email and download that here later tonight.
Okay, sounds good. I think we're about ready to build the RF modules, and I want to hold off a little on the clock module because I'd like John to get his test boards up and running and verify that everything's good before we go cast the things in stone.
Yeah, we don't, right now we don't have anything to plug them into anyway.
Right.
And if we had something to plug them in, we wouldn't have any FPGA to test it with. So we got so many roadblocks between us and testing.
Scotty, should we give a short update on the DCC planning, where we are? And
Yeah,
so
you probably know more than I do. So go
yeah,
ahead.
so basically we're having we had a meeting last Friday and we're having a meeting this coming Friday. We're expecting papers to be uploaded the first week of September, and John hasn't provided the link yet that I know of. Scotty, have you seen it?
No, I haven't. But Steve has extended the date to September 10.
Okay.
So that helps a little, but we have to have the place for them to load.
Yeah, so we're going to have those uploaded. We do have a team working on it, but it's a little fits and starts. But so don't get.
So we're early, but tomorrow when it's September, we'll be late.
Yes.
So
and people like Bill, who already has his stuff done.
He makes us all look bad.
Yeah.
That's papers for the printed.
No, the printed one should already been in.
I thought. So what paper?
These are the recording of
the
your
recordings, video. the videos,
yes,
not papers.
Sorry.
Yeah, okay, that makes a little more sense. Good.
And so there will be a I believe a Dropbox. I can't remember, and it will be open during that first week of September.
So it gives you plenty of time to record your presentation.
Yes.
And what else to it? Is the sign up page live, Dave? Do you know?
Yes, but as a couple of people here said, that the trouble is the sign up page is being monitored by Bruce, and Bruce lives in Spanish Fort, which is Mobile, Alabama.
In underwater territory?
He says his house is 100 feet above the bay, so I hope he's still okay.
Dave, a question. I signed up for DCC and I got an email saying to register for a Zoom account.
Yeah, I can fill you in a little about that, Tom. I got a note back from Bruce Raymond. It's on the blog and the DCC site. He said that was his error. Ignore that stuff about creating an account. Everybody will be registered. He just needs a little more time.
Okay, yep. Good info. Thank you.
But be aware that Bruce just went through a bunch of rain.
I think he's still going through the rain.
It probably isn't all over yet.
Yes. So he's on the east side of Mobile Bay is where he lives.
He's well above sea level, but how far is he from the shore?
I don't know.
If you look at the satellite view, the predominant rain bands are to the east of the storm, and they're all over through Alabama, all over to the Florida Panhandle.
Yeah.
So big time.
So that's Pensacola and Mobile.
But I don't think he got the winds that
he didn't get the winds, but he got
Louisiana got.
And it's slowed down to like 6 miles an hour or something, which means it's going to just dump rain for bad news. So I bet Steve's going to get rain in Tennessee.
Yes.
I mean, it's going all the way up that
in a couple of days or in a day or two.
Gosh, we could just get one of those drops up here.
What's funny is that there's a hurricane that came up the Baja Peninsula, the Gulf of Baja. It actually came up the west coast of Mexico in the Gulf of Baja, and it's all dissipated now, so you can't see it. But Hurricane Nora is sending rain bands up here, and we're going to get rain in Arizona from that hurricane.
Well, they reported that the trees in the forest around here actually have a lower moisture content than kiln dried lumber.
Yes.
Wow. So you cut the tree down and you build your house right away. You don't have to wait.
Yeah. Well, you have to wait for it to suck up a little moisture and stabilize.
Yeah.
Yeah, the joke is that the trees are kind of leaning towards the dogs a little bit.
All right. Well, I got to run. Thanks, guys. See you
Yes.
next week.
All right. I guess are we done, Dave?
Yeah, I think we're done.
See you next week, guys.
Scotty, I'll see you Friday.
See you
Okay.
see everyone next
Okay,
week.
everybody, 73 and be safe.
And I'll see
73,
you,
everyone.
Nathaniel, I'll see you Thursday
Yes, Thursday for
for the ham sci.
yes, we have the ham sci telecon
It
Thursday
starts
afternoon.
this Thursday at 3 p.m., right?
That's right. Yep.
Okay, Eastern.
Eastern.
Okay.
Yes. Great.
Sayonara.
Thank you.
Yep.
All right. Bye, everybody.
Bye.
Thank you.